All right, everyone. So this video is going to cover the solutions to the section 3 of the diagnostic test that everyone took. So without further ado, let's get into problem 1. So what this video is going to cover is basically a general solution to all the problems. I'm assuming that most of algebra is known, or at least you are familiar with that. And yeah, with that in mind, really what I'll just be discussing is, how to manipulate the problem, and if there's something important that needs further explanation, I'd be happy to explain that too. Great. So the first problem says, if x minus 1 divided by 3 is equal to k, and k is equal to 3, then what is x, right? So basically it's, a type of equation, right? So the first thing we can do is, since we know k is equal to 3, and this variable has 2 variables, right? And we want to just solve for one variable, the rest being numbers, right? We can just plug 3 in for k. So we can get 3 is actually equal to x minus 1 over 3. Simple enough, right? So then that's perfectly legal since k is equal to 3. The next step would be to multiply both sides, both the top and bottom, by 3, right? So we can remove this 3 on the bottom, right? Because we multiply by a 3 on the top, these two will cancel. And we will just get 3 times 3 on this side, which is going to say, okay, 9 is equal to x minus 1. Next step of this is adding 1 to both sides, which means that x is equal to 10. Perfect. And so therefore, D would be our answer. Great. So question 2 says, for an I equal to the square root of -1, right? Some imaginary value, right? The square root of -1 is not possible, and in math we denote that as I, right? And so they're asking us, what is the sum of these two things, right? And so something important to note when you're adding complex numbers, which is what this is, it has a real part, a real number, like a counting number 1, 2, 3, 4, 5, and then it has a part involving this number I, which is the square root of -1, right? And so anytime you see a number and then I next to it, like a number plus or minus some value with I, right? You're dealing with what's called a complex number, right? And so the way we deal with a whole expression like this is we'll simply add together the real parts. We'll combine like terms, and these are both real. We can add them together, and then we'll add together the parts involving I, right? And we can do this just by combining like terms, right? We're not doing any multiplication. When we multiply things with I, when I is the square root of -1, things do change a little bit, but since this problem doesn't involve that, all we need to do is combine like terms. Since we're just adding 2 quantities in parentheses, we can go ahead and remove those parentheses. So we'll just get 7 plus 3i plus -8, right? Put that in parentheses there because there's a negative. You don't have to, but I'm going to do it. So plus 8 plus 9i. Okay, we have a 7 and an 8, so we get 7 minus 8 on one side, and then we get 9i plus 3i. Great. 7 minus 8 is just going to give us -1, and 9i plus 3i, well, 9 plus 3 is 12. We just add the I in the end because we're dealing with terms with I. It's going to give us 12i, right? -1 plus 12i. And as I said in the beginning, right, these numbers involving I, where I is the square root of -1, we're going to have our real part, our real number here on this side, right? So our real, and then our part involving I. So this will be our imaginary, if you will, part, typically called imaginary, right? So our answer is therefore A. Great. Let us head over here and screenshot the next question. Question 3. Okay. So question 3 is a word problem, but that's not the fear because it's actually much simpler than it looks, because all we're dealing with is 2 quantities essentially being added to one another. The key of the problem here is just realizing that, well, it's simple enough in that we're using variables to represent what's happening with each person, right? And once we figure that out, it's easy to pick the correct answer, right? So it says, on a Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. They want to know which of the following represents the total number of messages sent by Armand and Tyrone on a Saturday afternoon. So Armand's sending M per hour, right? So Armand is sending M, right, per hour. So since he's doing it for 5 hours, it's just going to be m for 1 hour, m for the other hour, m for another hour, m for another hour, and m for another hour, right? 5m. The total of that will be 5m. Tyrone's doing the same thing. He's just doing it 4 times. P for 1 hour, P for another hour, P for another hour, P for another hour. Great. 4p. How many messages are they sending in total, right? Well, it's as simple as just adding them together, right? Because in total, Armand's sending 5m quantity, 5m total text messages. We don't know what m is, but we do know it's a number, sending 5m total, and Tyrone is sending 4p total. So total is just 5m plus 4p, and that is C. Great. Question 4, another word problem. Perfect. Let's take a look at question 4. Okay, so question 4 gives us an equation, and it's going to ask us to elaborate on what each part, what one or more parts of the equation mean. In this case, they just want to know what the value is, but in other problems, they might want to know what the variables mean and things like that, right? So it says Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of the day can be estimated with the equation P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days she has worked in the week, right? And they want to know, what does 108 mean? So what does that initial numerical value mean, right? So how do we figure this out, right? We kind of have to look at the answer choices to know, right? Because, I mean, it could mean anything in the context of, well, it does mean one thing, but the easiest way to approach this problem is just to look at the answer choices and see what makes logical sense, right? So let's take a look at A. Let's rule out answers, right? It says Kathy will complete the repairs within 108 days. Well, that doesn't really make sense because P, right, is getting smaller, right? So eventually P will become 0, right? And if we look at the value of D, right, which is the number of days she has worked that week, right? If D was 108, right, then we'd have a negative number because 23 times 108, 108 minus that is going to give us a very tiny negative number. So clearly the phones can all be fixed, right, in less than 108 days. So A is incorrect. It's good. Whatever the number is that P becomes 0, right, it's going to be far less than 108, right? So let's take a look at B. Kathy starts each week with 108 phones to fix. Well, in looking at this, right, as the number of days goes up, so as days increases, right, that 108 is decreasing, right, and therefore the P, right, not the 108 is decreasing, right, but yes, in a sense, the 108 is decreasing, right? So as the D increases, right, then there's more being taken away from the 108. So we'd have, for example, 108 minus 23 on day 1. And then the next day we'd have 108 minus 23 times 2. As time goes on, that 108 is getting smaller, right? And that means that the number of phones left to fix is getting smaller, right? And so logically, right, Kathy's going to start out each week with 108 phones to fix because once that day number gets high enough, that number of phones is going lower, right? So as she works more days, the 108 that she started with is decreasing to 0, and by the end of the week or so, or the number of days she's worked, she'll be left with 0 on the other end. So that's the way to think about it, right? She's not fixing them at 108 per hour. That doesn't even make any sense. There's nothing dealing with hours in the problem. We can neg out C. Even though the answer is B, we can see why the other 2 answers are incorrect. And she's repairing phones at a rate of 108 per day. Well, no, right? Because we can see that, D is the number of days she's worked that week, right? She's fixing 23 phones per day, right? Because the 108 is being decreased by 23 each day, right? So it's clearly not D. So therefore, the correct answer is B in this scenario. Great. All right, let's take a look at question 5. So question 5 is sort of an algebra review question, which is going to involve us combining like terms, right? So that's just terms that contain the same, sorry about that, the same parts being multiplied by one another, right? So that just means like, okay. Strange. There we go. So it says, which of the following is equivalent to the expression above, which basically means since all the answers are smaller than what's given above, we just have to simplify this, right? And so we have terms like we have x squared y, we have 3y squared, and we have 5xy squared, and then we're subtracting this whole thing, which is negative x squared y plus 3xy squared plus 3y squared. And we have some like terms here. So what that means is terms with the same parts, right? So x squared, this one has an x squared and it has a y being multiplied by one another. And this one here also has an x squared and a y being multiplied by one another. So those are considered like terms, right? So we can underline the like terms here in different colors. Wow. That's a like term, that's a like term. And lastly, oh, that's a like term and that's a like term. And so we can combine these, right? But the first step we have to do is handle this minus sign, right? And so when we have a quantity in parentheses like this, we have to do what's called distributing the minus sign. We have to multiply each part by the minus sign. Since we're essentially minusing the whole thing, we have to multiply each part by the minus sign before we open up the parentheses. So let's go ahead and do that. I'm going to rewrite the whole expression here. So x squared y minus 3y squared plus 5xy squared. And then this minus and minus is going to become a plus x squared y, right? Then we have a minus 3xy squared. And then we have a plus 3y squared, right? Great. So right ahead, let's take a look and see what we can combine here. So right off the bat, I see, well, this can go and this can go. And secondly, I see I have two of these, this and this, right? So that's going to give me, I can start writing my answer of 2x squared y. Great. And then lastly, I have these two parts here. These have to be combined. So this is the third color here, which is going to give us 2xy squared. So that's going to be plus 2xy squared. Great. And that would be our final answer. We can see that's choice C. And that is correct, right? All we did was some simple algebra. We combined the like terms. Perfect. All right, let's take a look at question 6. Question 6 gives us an equation again, and we have to, again, similar to question 4, we have to sort of explain what certain parts of the equation mean. Okay, question 6. So it says, pediatrician uses the model above to estimate the height given as h of a boy in terms of the boy's age, a in years. Age, of course, given as a, between the ages of 2 and 5, so it's constrained. It's not really important, but it is between the ages of 2 and 5. And based on the model, what is the estimated increase in inches of a boy's height each year, right? So how much taller is the boy getting each year is basically the question we have to answer, right? Using the model, nothing else, just the model. So let's do some guess and check here, sort of plugging in inputs and inputs to the model to see how much the height is changing, right, per year. Great. So okay, so for 2, right, when the boy is 2, h is equal to 3 times 2 plus 28.6. And when the boy, this is at 2, right, and when the boy is 3, that's the height will be 3 times 3 plus 28.6. So if we were to calculate this, right, then add 2 and add 3, then the h is equal to, respectively, we'll have 6 plus 28.6, which is 34.6. And we'll have 9 plus 28.6, which is 37.6. And so if we look at the increase, per year, right, we can see clearly this is going to be plus 3. That's our increase. And knowing that, we can select the correct answer. And because this function is, it's adding 3 each year, if we look at the 3a, the age is increasing by 3 each year, it's going to be the same for the 4 and 5 increase as well. But we can evaluate this easily by just looking at an example here. Great. Okay. So let's take a look at question 7. Question 7 can look intimidating, but it isn't, just because it's almost like the maker's test are trying to trip you up, right? But while this may look complicated and confusing, in reality, there's nothing crazy going on here. It's just some fractional manipulations, right? We just have to evaluate this in a clever, or sort of, we have to make a judgment about this that allows us to solve it, right? So it says the formula above, it gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over a period of N months. Which of the following gives P in terms of M, R, and N? Okay, so right now we have an expression in terms of M, right? We have an M solo on one side, and we have this sort of clump being multiplied by some number P dollars, right? And so if you remember, right, if we have a fraction, let's call it A over B, right? And we multiply this fraction by B over A, right? It's reciprocal, so to speak. It's inverse, right? Then we will get 1, right? And we know that 1 times x is x, right? So essentially, we're isolating something. Suppose this was being multiplied by P, for example. We're isolating P, right? So by multiplying by the reciprocal, we're isolating that part, right? So we're going to do the same thing. We're going to isolate P by multiplying this thing by the reciprocal, right? So we have this thing, this R over 1200, whatever. We don't need to read the whole thing because that's not really important. But what we do need to do is notice that we need to multiply by the reciprocal of this part here, on both sides, right? Because when we multiply by the reciprocal of this on both sides, we'll get P on one side and we'll get something else on the other side, right? So let's do that over here. So if we were to multiply by the reciprocal on both sides, we'll get P, right? Suppose we did that, right? We'll get P is equal to M times the reciprocal of this, since that will cancel. When we multiply the reciprocal with P, we'll get M times the reciprocal of this, which would be 1 plus R over 1200 to the N minus 1 divided by R over 1200 times 1 plus R over 1200 to the power of N. Great. And that would be our final answer. Right? We can see that is B. Right? All we did here to isolate P was multiply by the reciprocal on both sides, and in algebra we do things on both sides, right? So then we just have to remember to multiply by reciprocal on the side with M, and then we're done. Okay, let's take a look at question 8. Question 8 is very similar to the last question. Again, a problem dealing with fractional manipulations here. Question 8 states that if A over B is equal to 2, what is the value of 4B over A, right? So as we know, right, when we take the reciprocal of something, we're taking the inverse, right? So a good way to think about this right now is we know that A over B is equal to 2 over 1, right? So that means that if we cross multiply here, algebraic technique there, then A is equal to 2B, right? And so if A is equal to 2B, right, then B over A is equal to 1/2, right? We're just taking the reciprocal there. So if we know that by taking the reciprocal, this is like 2 over 1, we're just flipping this, right? Then B over A is equal to 1/2, right? Then they want us to find 4B over A, then all we have to do is multiply this by 4 over 1, right? Because that'll give us 4B over A just by fractional multiplication there. Okay, great. 4 over 1, perfect. So then that means that 4B divided by A is just 4 over 2, which is just 2, right? That's all we got to do there. Final answer is 2. It's very similar to the last problem, right? We're using that concept of reciprocal to get the answer correct. All right, so let's take a look at question 9, which is a system of equations type problem. So the way we have to solve this is using a technique called substitution, where essentially what we're going to do is isolate one of the variables. So we'll get an equation in terms of x, right? And then we'll plug in that equation in terms of x into another equation, the second one, to get a single variable equation, right? And then we'll be able to solve for one of the variables. And then once we solve for one of them, we can plug that one into the other equation to get the other. So this is a bit of a complicated process, but I'll show, kind of demonstrate with this example here. So let's isolate x. There we go. Okay, so x is equal to 2y plus 19. We can see that because I just moved x to this side and 19 to this side, canceling the negatives, and now we've isolated x. So once we have x, we can plug x in for the 3x here, right? So we get 3 times 2y plus 19 plus 4y equals negative 23. Okay. Now we can solve this just by using distribution and some consolidation on both sides here. So we'll get 6y, we're sorry about that. 6y, range for that. 6y plus 57, right? That's 19 times 3, plus 4y is equal to negative 23, right? And now we can subtract 57 from both sides, minus 57. So we're essentially adding these, then we make them negative, right? So 7 plus 3 is 10, 3 to 1, that's going to give us 80. Okay, so then we can add the y's together. That'll give us 10y is equal to negative 80. And then we know that y is equal to 8. And if we look at our, negative 8, sorry. And if we look at our answer choices, right, only one has a y value of negative 8. And so by elimination, we know that this is going to be the correct answer, B, because, well, we can only have one, since there's only one answer with the correct y counterpart here. So that's all we need to do to move on with the problem. And that's pretty much it. Sometimes you would have to solve for the x, and you would do that by taking the negative 8 and plugging it back into this equation in terms of y, and then you could solve for x, right? Which it comes out to be 3, but you don't need to do that here. All right, number 10 gives us a function, and it says we're given the function g of x is equal to ax squared plus 24. It says for the function g defined above, a is a constant, and when you plug in 4 for x to g, you get 8. And then they're asking us to find, okay, what's g of negative 4? So when we plug in negative 4, what do we get? And so the way to look at this is, okay, let's plug in 4, right? So we'll take g of 4, right? And we'll be able to solve for a, and I'll show you how we're going to do that. We'll say g of 4, okay, equals 8, right? And that's also equal to a, right, times 4 squared, since we're plugging in 4 for x, plus 24. And if we look at this portion here, we'll notice, okay, this is actually the 16a plus 24, right, is actually equal to 8, right? Since this is g of 4, and this is the output of g of 4, which is 8, right? So now we can actually solve for a using this, right? Since when we plug in x, we actually can isolate a, right? We're given essentially a point on this function that can help us identify what a is. So let's go ahead and solve for a. So we'll get 16a is equal to negative 16, and that means that a is equal to negative 1. And since a is equal to negative 1, then we know that g of x, right, we can just plug in negative 1 for a. That's just going to give us negative x squared plus 24, right? And now that we have our full function, to find g of negative 4, all we need to do is plug in negative 4 to this whole function, right? So we'll get g of negative 4 is equal to negative, right, negative 4 squared plus 24. Keep in mind that you're squaring the whole of negative 4, right? You're not, the minus signs will not cancel. So we'll get negative 16 plus 24. And this is question 10. And our answer is going to be 8, right? Because when we plug in, we have a negative 16, we have a 24. And so that just gives us an answer of 8. Perfect. That's going to be A. Great. So that's simple enough, right? Just the important thing to remember here is when you plug in 4 to a function like g of x, it's the same thing as it's just an input and you're going to get an output. So once you know that, you can solve the problem pretty easily. All right. Now, question 11 says, in the equations above, B and C, right? B and C both represent the price per pound in dollars of beef and chicken, respectively, X weeks after July during last summer. It's kind of irrelevant. All we need to know is that we want to know what is the price per pound of beef when it was equal to the price per pound of chicken. So the first way to approach this problem is, okay, well, B has to be equal to C, right? B has to be equal to C. So we can, and we know this is B and we know this is C. There's X's in both of them. Don't worry, that's going to get sorted out, right? But we know that B is equal to C. So let's make that clear. 0.25x is equal to 1.75 plus 0.40x. Right, since we know that B is equal to C, then we can actually use this. We now have an equation where we can solve for X, right? And once we solve for X, then we can find the price per pound of beef, right? This is just telling us, okay, they're equal. Once we found X, we can actually evaluate what the price per pound of chicken for beef, the price per pound of beef will be, right? So let's go ahead and solve this. This is just a relatively simple decimal equation. we're just going to subtract, the first thing we're going to do is subtract 1.75 for this side, right? We can treat these as hundreds and then bring the decimal point down at the end. It's going to be 0, 1, 13, and it's going to be 6, right? 13 minus 76, this is going to be 0. So the answer is 0.60, right? So that's 0.25x is equal to 0.40x, or 0.4x. Then we subtract the 0.25, right? That gives us 0.15x is equal to 0.6. So this means 60 is equal to 15x. That means x is equal to 4, right? And so now that we found x, right, all we need to do, right, we found x when they're equal. So now we actually know what the prices will be, right? All we need to do once we find x is plug x into the b. So we know that b is equal to 2.35 plus 0.25 times 4, which is x, right? This is going to be the price when they're both equal. And that evaluates simply, this is just 1, right? Because 25 times 4 is 100, so 0.25 times 4 is 1, right? So it's just 1 plus 2.35, which is equal to 3.35. That's the final answer. It turns out to be D here. Great. All right, let's move on to the next one. So number 12 says a line in the xy plane, okay, it passes through the origin, so it contains this point, right? 0, 0, so they contain, don't know why that's happening. There we go. It contains the point 0, 0, right? And it also has a slope of 1 over 7. So the slope of 1 over 7 means essentially up 1 from this origin and then over 7 to the right. So as you know, slope, right, basically means rise over. And so basically what this 1 over 7 is telling us from the origin, right, the next point on this line, right, is going to be 1 up and 7 to the right, since the right is positive. So if we were to draw this, right, the xy plane here, this is 0, 0, it's at the origin. The next point, this is 1, right, and this is 7. So we're consistently going up 1 and over 7, right, for intervals in this, right? So this point would be 7, 1, right? So that's 1 point on this line, right? They're asking which of these following points lie on this line. So right away, we can remove answers, right? Since we know that we have to go up 1 and over 7 to get to each new point, right? We know that this is going up 7 and over 0, so that's not correct. This one's going up 7 and over 1, so that's 7 over 1, not 1 over 7. This one's going up 7 and over 7, that's not 1 over 7. And we can see that D is the answer because since our first point, we go up 1 and over to the right 7. That's what this is telling us. Our second point is also going to be up 1 and over to the right 7, right? So this is a 2 here. That's not the best drawing. And this is a 14, right? Same rule. This point would be 14, 2, right? The slope is essentially saying, okay, in any slope, say the slope is A over B, right? This is going up or down, right? If it's negative. And this is going left. Sorry, right. To the right, right. Just like in the 1 over 7. It's a good rule of thumb to remember. Great. So the answer is 14, 2. All right. Let's take a look at number 13. So 13 is asking us to do some algebraic manipulation. They want to know which of the following is equivalent to 1 over x plus 2 plus 1 over x plus 3. So we have to find the correct answer here, right? And so right off the bat, the first thing I'm going to do, right, to approach this is to create a common denominator for both fractions. So for this one, I'm going to multiply it by, because I want to add them, right? So I'm going to multiply it by, my goal is to add them and then reciprocate this. It's 1 over, so I can flip the whole thing, right? And then get a simplified answer. So I'll multiply this by x plus 2 over x plus 2. And this one will be multiplied by x plus 3 over x plus 3. Once I do that, I'll get an answer of 1 over 2x plus 5, right? Because I'm adding x plus 3 and x plus 2 on the top. And my denominator will end up being x plus 3 times x plus 2, right? Because that's common. And remember, when we take 1 over something, right, we're essentially taking the reciprocal of the thing on the bottom. So we can end up by a law of fractional manipulation, so to speak, we can end up flipping this thing, and this actually becomes equal to x plus 3 times x plus 2 over 2x plus 5. And notice that this is a factor, this is a factor, this is a factor. When you have the same thing on the top and bottom being multiplied, right, they can cancel, but we don't have this case here, right? 2x plus 5 is different from x plus 3 and x plus 2. And so whatever this is our final simplification, right? So if we FOIL this out, right, we can expand it, right? But it's going to be divided by 2x plus 5, right? So right, using that, we can tell that B is going to be the answer, right? Because none of these other things have a base of 2x plus 5, but let's go ahead and expand this. So we can use the FOIL technique, right? So with given two things in parentheses like this, we'll multiply the first two terms, then the outer two terms, and the inner two terms, then the last two terms, right? Great, so that'll give us, if we make the top, it's over 2x plus 5, x squared, right? X times x squared, plus 2x, then plus 3x, it's gonna be plus 5x, and then lastly plus 6. So we can see that's B, right? On a test, you could save time. You would be able to identify this as the correct answer just by knowing this. But, it's good to practice by fully expanding out. Great. So 14 is a bit of a tricky one. Took me a little while to get this on my first pass on this when I looked at this test a while back. But the key to this one is knowing that things like 2 squared is 4, right? Like these are equivalent, right? We can use this form to do things with the 4 that we couldn't do when it was just a 4, right? So let's read the problem. So it says, if 3x minus y is equal to 12, then what is the value of 8 to the x divided by 2 to the y, right? So we're given this little piece of information here, and we're given this expression, right? So somehow this is going to relate to this, this 8x over 2 to the y, but let's see why. And so the key is in the laws of exponents, right? So we know that when we have two exponents with the same base that are being divided, like 2 to the a over 2 to the b, it's just a law. This is equal to 2 to the a minus b, right? These are the same base. But here, if we look, these aren't in the same base readily. So what we have to do is we have to make them the same base. So we'll say, okay, 8 to the x. What is 8 to the x? Well, 8 to the x is 2 cubed, right? 2 cubed is equal to 8, and 2 is the same base as 2 to the y here. So it's the same thing as 2 cubed to the power of x, right? Because another law of exponents says, okay, when we have something like this raised to the power of x, we're actually just going to end up multiplying these exponents together. So this is going to give us 2 to the 3x, and that's equivalent to 8 to the x, right? So now we can rewrite the expression like this. So we'll get 2 to the 3x divided by 2 to the y, right? And once we have this, well, okay, we can apply this law over here, and we'll get 2 to the 3x minus y. And then, well, right, this piece of information they gave us here, this is relevant, right? Because this makes the problem a lot easier. Now that we know that 3x minus y is equal to 12, right? Then this is just 2 to the 12, right? Just by plugging it in there. And we can see that A is the correct answer, just based on knowing that 2 to the 12 is this, right? So the problem is a bit trickier because you have to realize that 8 to the x is 2 to the 3x. But once you realize that, it's definitely doable. Great. So 15, again, it's a little bit of a trickier one, but let's go through it. All you have to remember here is A, the FOIL technique, and B, factoring, and how factoring relates to things like the number in front and the number at the end, right? So it says if ax, in parentheses, ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14 for all values of x, and a plus b is equal to 8, right? What are the two possible values for c? So they want to know, okay, what could c be if this is true, right? So it's a bit complicated, but let's just take an approach. Let's begin by foiling this out, right? So if we FOIL this out, we'll get the first terms is just a times b times x squared plus 7ax plus 2bx, and then the last term is 14. And we know that this is equal to, I'll write it on the bottom here, just kind of show what I'm trying to do here. I'm going to put this in parentheses. Plus cx plus 14. So if we notice here, we're given some information, right? So we know that this 7ax plus 2bx has to be equal to cx, right? This is going to evaluate to some constant, right? And we don't, just based on the fact that this has an x in front, this has an x in front, this is cx. So when if these two were added together, they're going to be equal to cx, right? Because they have the same degree and the same variable, right? And we also know that since this is 15 and this is abx squared, well, we know that a times b has to be 15, right, to make this true, because if a times b isn't 15, then this number isn't 15. And since these are the same part, these are the same, part, right, they both, a plus b has to be 15 for this to be true, because this will be something 15x squared plus cx plus 14, and this is 15x squared plus cx plus 14. The x squareds match up, the x's max up, and the numbers match up, right? So we know that ab is equal to 15, right? And we also know that a plus b is equal to 8. Right? And so, okay, so now we have a system where we can solve for what a and b could be, right? A and b, they could be individual numbers, or they could be they could be mixed up, right? So there actually will end up being two different combinations at the end here. But let's solve the system. So how do we do this, right? The first step is we're going to do it using substitution, and we're going to divide both sides by b. We're going to say a is equal to 15 over b, which means that 15 over b plus b is equal to 8. And then we're going to multiply both sides by b. We'll get 15 plus b squared is equal to 8b, which means that b squared minus 8b plus 15 is equal to 0. This is a quadratic, and we're going to solve it, right? We want to find out what b is. We can actually factor this out, right? So if I put two parentheses here, I want to figure out, okay, so what expression can I put here that if I FOILed it out would get me back to this, right? So clearly, if I put a b here and a b here, I'm going to get a b squared when I FOIL, right? So now I have to figure out, okay, what two numbers multiplied to negative would add together to give me -8 here, and would multiply to give me 15. Well, if I put -5 and -3 here, I get b squared outer minus 5b minus 3b plus 15. So that works. So these two parentheses will give me the correct answer. And if we're familiar with quadratics, then we know that our solutions, we can set each individually equal to 0, right? Because when one is 0, the other is 0. So we know that our solutions will be given by b minus 5 equals 0 and b minus 3 equals 0. So that we know b is equal to 5 or b is equal to 3, right? And by that logic, right, once we find b, we'll also find, okay, a and b could either be 5 or 3 or either, right? So a could be 5, b could be 3, and a could be 3 and b could be 5, right? Because both make the equation true. So this is how we're going to get two values of c. So the first step, okay, so we have the 7, now we'll go back to this thing in the middle here. We have a 7ax plus 2bx, right? So now we can find out c, right? Because we know that a could be 5 or a could be 3 and vice versa. So let's evaluate c. Let's assume a is 5 and b is 3. So if a is 5, we'll get 7 times 5x plus 2 times 3x. So that gives us a value of c that's 41, right? And similarly, if a was 5 and b was 3, then we'll get 2 times 5x plus 7 times 3x, which will give us a value of 31 for c, 31x. So this is c. So we can interchangeably plug in both values of a and b back in to find out what c would be once we found what a and b are. And clearly, they're 31 and 41. So we can circle that answer. This is a bit more of a complicated problem. You have to be sort of more familiar with quadratics and the manipulation going into them. And once you know that, and you see that, okay, let's just look by inspection, right? A could be 5 and a could be 3 or vice versa, right? Because 3 times 5 is 15 and 3 plus 5 is 8. So once we know that, okay, a could be 5 or 3 and b could be 5 or 3, and this whole thing is c, I know what a and b is, right? I can get two different values for c, right? That's just the important thing to know, which are 31 and 41. If you went through this problem too quickly, you might think they're 3 and 5, right? That's not the correct answer. That is an answer, but it's more of a careless mistake. All right, great. So let's move on over to the the short answer response part of the test. These are kind of important to get right. Sometimes they're simple, sometimes they're a little bit harder, right? That's all right. And they'll oftentimes get harder as you go on. But let's take a look at the number 16 here. 16 says, if t is greater than 0 and t squared minus 4 is equal to 0, okay, so we have an equation here. What is the value of t? So the first step I would do is, let's go ahead and solve this. Let's say, okay, t squared minus 4 is equal to 0. So that means t squared is equal to 4, right? And okay, so I can take the square root of both sides, right? Two numbers, that 2 squared is 4, right? 2 squared is equal to 4. And we also know that -2 squared is equal to 4, right? So our solutions could be t is equal to -2 or 2, right? Perfect. But they tell us that t has to be greater than 0, right? And so immediately we can say, okay, we can exclude this solution because -2 is less than 0, and so it's not part of the solution set. So therefore, the value of t that they're looking for in this problem would be 2. right? Right. So you'd write 2 on the answer sheet. That is correct. All right, number 17. So number 17, number 17 involves what's called similar triangles. So similar triangles, some of you may be familiar with, some of you may not, are triangles where all of the angles are congruent. All of the angles are congruent to each other. So if we see we have angle E and angle D are congruent, right? Angle B and these 2 angles are congruent, and these 2 angles are congruent, right? And these have sort of special properties. So let's take a look at the information they gave us. They say a summer camp counselor wants to find a length x. We're trying to get AE here in feet across a length as represented in the sketch above. So the lengths are represented by AB, EB, BD, and CD. So there's these segments here. So AB is 1800. EB is 1400. Okay. BD is 700. Okay. And CD is 800. Okay. Right. If you guys are familiar with vertical angles from geometry, right? If we look at these two angles are congruent just by the definition of vertical angles. This sign means they're the same measurement, right? And that just means, well, since they're created by a pair of 2 intersecting lines, they are equal. Just a kind of a definition there. Okay. So now we have this angle here, this D here, and we have this angle E here. These are congruent. They're drawn as such, right? We also know that these 2 angles are congruent, and we know that this when you add up all the angles of in a triangle, they equal 180, right? And so since these are congruent, right, this last one also has to be congruent, right? Since we have these 2, which are these 2. So suppose this was 30 and this was 40, right? Then these 2 would be 70, right? We don't know the measures, right? And that means that the biggest one would have to be 110, right? Same thing in this triangle. Like they all have to add up to 180. So when you're given 2 that are the same, then the last one also has to be the same, right? So therefore, we also know that this is congruent, right? So now we have these 2 triangles are therefore similar, right? And they're similar because they have all of their angles congruent. And similar triangles, while are not congruent themselves, they are sort of ratio duplicates of one another. So if I were to give you an example here, and I draw 2 similar triangles out, these 2 triangles are similar. Let's assume they have the same angles, just for this. All their angles are congruent. And what this means is that their sides are actually in ratio to one another. So this is sort of a definition to know. If this side was 1, this side could be 1/2, right? They're in sort of a ratio. If this side was 2, then this would be 1. If this side was 3, then this would be 1 and 1/2, right? So they're sort of in ratio with one another. These triangles have a 2-to-1 ratio. This is a property of similar triangles. They always have some sort of ratio. The sides always correspond to the other side in some way, right? Corresponding sides. They're sides that are opposite the same angle, right? So 1 is opposite the same angle here. 2 is opposite the same angle here, right? So therefore, these 2 sides are in a ratio of 2-to-1. Same thing with all the others, right? So let's take a look back at the original problem. We see that there's a 700 here, and it's opposite this angle, right? And we also see that there's a 1400 here, and it's opposite the same congruent angle. And so what this tells us is, okay, these triangles are in fact in a ratio of 2-to-1, right? Because 700 times 2 is 1400, and the corresponding side here, this 1400 is 2 times 700, right? And so we know that, therefore, by definition of similar triangles, that all of the sides that are opposing the same congruent angles will be in a 2-to-1 ratio, right? Where this triangle is the 2 and this triangle is the 1. And so we're trying to find x feet. And if we look at this side, 800, well, we see that our x side is corresponding the same angle, right? And these triangles are similar. And so therefore, since these triangles are in a 2-to-1 ratio, our x side is actually going to be 1600, right? Just like 700, 1400, 800, 1600, right? It's going to be 1600 by the logic of similar triangles and the fact that these triangles are congruent, right? Congruent just means same measurement, for clarification if anyone's confused on that. Great. So that means that x is equal to 1600. Perfect. All right, number 18, another systems of equations problem. So that just means it's another system. It's very similar to one of the problems we just did. I think it was number 10, I believe. And so we're just going to solve this the same way we did there. We're going to find x. We don't need to find y necessarily, so we can just solve for x. So that means isolating y, right? So let's isolate y. That means that y, in this case, let's isolate y from this equation by subtracting x from both sides, right? Minus x. So that means y is equal to negative 9 minus x, right? And that means that since we know what y is, we can plug y into this equation. We'll get x plus 2 times negative 9 minus x is equal to negative 25. So we'll get x minus 18 minus 2x is equal to negative 25. That means that negative x, we'll add 18 to this side, plus 18, is equal to negative 7. And that means that x is, in fact, equal to 7. Just by isolating y, plugging y into this equation, getting a single variable equation, and solving for x. And that's simple enough. Doesn't take very long. The key is just not taking x out, finding y, and then plugging y into this equation. Because when you find x out, you'll end up solving for y. It'll take a little bit more time. It's nice to get to these as quickly as possible. Great. Number 19. Okay, so we're given a right triangle. It's a good idea to, when these have things like sine and cosine in them, which are trigonometric terms, it's a good idea to draw the thing. When these problems are simple like this, like when they're just asking for one thing, it's a good idea to draw it. So it says in a right triangle, we'll give that a 90-degree angle there. One angle is measured x degrees. Let's call this one x. And the sine of x, right? Let's recall or introduce the fact that the sine of x, right, is equal to the opposite, right? The side opposite x over the hypotenuse of the triangle, right? So in this case, the sine of x is the side opposite x, right? Side opposite here over the hypotenuse. So it's 4 over 5, right? Or some ratio that corresponds to 4 over 5, right? We can write it this way because, well, it doesn't matter as long as the ratio is 4 over 5. You could use any numbers that simplify to 4 over 5, right? And they're asking us, okay, what is the cosine of 90 minus x? Right, so what is the cosine? And let's remind ourselves that the cosine of some number, let's call it alpha, is equal to the side adjacent to alpha divided by the hypotenuse. Right, so what is the cosine of 90 minus x? How do we find this? Well, we know that all of these angles added together, let's call this angle alpha here. We know that all these angles added together will give us 180. We want to find, okay, what angle here equals 90 minus x? So we have 90 and we have an x, right? So we have x plus 90 plus alpha is equal to 180. Because we know that the sum of all the angles in a triangle is 180, right? So let's find out what alpha is, because alpha may be equal to 90 minus x. And if we know that, right, then we can solve the problem here. So alpha, therefore, is equal to 180 minus x minus 90, which equals 90 minus x. So alpha is equal to 90 minus x. So we can actually take the cosine of this angle to find our answer, right? And if you think about it, right, it makes sense that alpha would be 90 minus x because we have a 90, we have an x. The last angle, therefore, has to be 90 minus x for all the angles to equal 180, right? So alpha is equal to 90 minus x. So we're evaluating the cosine of alpha. So the way to do that, right, what side is adjacent to alpha? Well, it's 4, right? This is the side opposite, and this is the hypotenuse. So the cosine of alpha, which is 90 minus x, is equal to 4 over 5, right? Which is the same as the sine of x. So this is actually kind of an important fact to remember. Well, we know that the sine of x, right, is something, right? But the sine of x is also equal, this is just kind of an identity or effect, to the cosine of 90 minus x, right? Which is kind of what we showed to solve this problem. But this is a little tip to remember, right? You can draw it out like this, you can reason through the problem, but it's also good to remember that when you have the sine of x, the opposite of x, the opposite side to x over the hypotenuse, that's actually equal to this angle in a right triangle, the cosine of 90 minus x, right? They're the same thing, right? And that, if you think about it, it makes sense, right? Just by this example, and you could always draw it out on your own if you're confused. Or, of course, you could leave a comment, and I will try to, I will answer it. Okay, so let's move on to the last problem in the set, which isn't not a terrible one for number 20. Sometimes number 20 is quite difficult, but this one is pretty straightforward. Just some square roots involved, but don't be intimidated by those. So we have a is equal to 5 root 2, and we have 2a is equal to the square root of the whole square root of 2x. Okay, I want to find x. So right away, it's a very similar to problem 1. Let's plug in 5 root 2 for 2a. So we'll get 2 times 5 root 2 is equal to root 2x. Okay, which means that 10 root 2 is equal to root 2x. And well, how do we go from here? Well, we can just square both sides, right? Because when we square both sides, if we square root 2x, we'll get 2x, right? Because root 2x times root 2x is 2x, right? And if we square this, we'll get 10 squared times 2, right? Because 10 squared is 10 squared, right? And root 2 squared is 2. This is equal to 2x, right? Then since we have a 2 common on both sides, we can just cancel out the 2. Then we'll get x is equal to 10 squared. And of course, 10 squared is just 100. So our final answer would be 100, right? Simple enough. Just have to remember to square both sides there, and have to remember that, well, root 2 squared is 2. Another interesting fact is that 2 divided by root 2, right, is root 2. And that makes sense, right? But because obviously when you divide a number by its square root, you'll get back to the original number. Oops, just doing that again. Okay. Well, that is all of the problems in section 3. I hope you guys learned something from this video, and I will see you guys in the section 4 video. Great.